Hello everybody, this is Claudio Gatti from Claronav. This short video is a demonstration of our 4th generation Micron Tracker. First of all, the Micron Tracker, you can see it on here. It's a robotic camera with motors that will move both the eyes and the neck. And we're going to shortly see the performance of the camera running. But just to give you a preview, this is a typical tool of the Micron Tracker 3, the current generation of the device with 360-degree visibility. We have recently extended the markers to be more relaxed, so you can actually have a collection of X points to generate 360 on a solid angle from any orientation. And here you can visually see the introduction of the new Micron Tracker 4, how it will impact the size of the marker. So they become, in each dimension, 3 times the size, so become a completely unintrusive and can be embedded as part of a tool. Micron Tracker 4 will support a different type of attachment, all with a very compact marker that will give full visibility. And you can also see it on a reference marker. This is a Micron Tracker 3 reference marker that we use in one of our applications. And you can see how it shrinks with Micron Tracker 4. All this is done with processing on board inside the FPGA of the camera with high resolution, 12 megapixel resolution in total for the camera. And we're going to see the performance of the camera running. Here you see the industrial design of Micron Tracker 4, which similarly to Micron Tracker 3 maintains this anthropomorphic feel, which our customer has told us that they appreciate. It gets also enhanced by, you can see the motion of the eyes up and down and the motion of the neck left and right. The motion is obtained with the brushless motor. We're very high quality, completely silent, and we also have the LCD where we'll be able to display appropriate message, and the ring light LED that will provide information on the status of the camera. Here is the detection of Micron Tracker 4. Here you have a tool that, this is a Micron Tracker 3 tools, which as we mentioned, it has now what we call an XPA, a collection of X points. So it's a 360-degree on a solid angle arrangement that allows the tool to be viewed from any orientation. Here we'll just show you that the Micron Tracker 4 with a resolution of 12 megapixel shrinks the size to a third of the size in each dimension. So essentially about 10 times smaller. So here you see the design of the same tool, but done with Micron Tracker 4 resolution that becomes completely unintrusive and embedded inside the tool with 360-degree visibility. It's also another characteristic of Mt4 is other than the resolution, is the dynamic range. And so far we've been running in round exposure, but the Mt4 has a 14-bit sensor. So here you can see we have closed the shutter to basically essentially a completely dark image, and we continue to have full detection. And on the other end, we can also open the shutter all the way to the top and still have very good detection. So essentially this allows the Micron Tracker 4 to adapt to all kinds of different lighting conditions. And the reason we can run at high resolution is that the logic for detection is now embedded into the camera in the FPGA, and you can sort of barely see it here, but if I put in some other tool, you will see that right now we are in ROI mode. So you can see that this is the only data that is sent from the camera to the computer for the final detection, and it's reducing the bandwidth dramatically, which is why we can have such high resolution in the detection. We're going to show you another functionality of the camera, which is the camera is robotic, so it has motors for controlling the eyes and the neck. And the idea is that when you are you have a reference marker in view, you can control that essentially the reference marker will stay always in the view together with the tool, and so you can sort of keep it, and as you go back, it will start moving the other direction. And so this essentially eliminates as much as we can the manipulation of the camera that now are common for navigation system. Let's go back to the center here, and now we can also do it going up and down. So as we start moving up, it will extend the view. Right now, this is you're seeing a simulation of this, but that's the operation of the camera when it will be production level. Thank you.